But if we include the electromagnetic field, now we have to add what? We have to add, we have to add the potential energy. Okay? But what's the potential energy? Okay, so sa ato pa, this would be integral of ds plus what? The potential energy, okay? The potential energy of what? No? Well, this is actually some sort of, let's just call it du, em, no? Okay. Du em, that's the potential energy. But, okay, let's separate this one. So we have ds plus, well, we have this one. What is now, what do you think, how do we calculate the electromagnetic potential energy? We don't need, we have already done this one. And as for now, this is not our concern. Okay? Ang atuwa is kani, what's the potential energy? How do you calculate the potential energy? Well, of course, we know that that's actually the charge times what? The potential, right? That's the potential. So, it would actually make sense, no? If we take this one, this integral is actually some q, okay, times the potential function. Ha? Oh, mao ni ang phi gani ha. Okay? We will be tempted to do this, right? Integral of this. And then with dt. Okay? But well, it turns out that this is not correct. But this is our guide here. Because we know that phi is actually related or just a component of the what? Of the 4-vector potential. Right? So sa ato pa, kung anang this one might be an integration, okay, over a line. Actually, this is a line integral. A line integral over what? We can think of this as something like, well, we add like, since this is 0, I mean, this is A0, right? So, we might think of this as something more formally like Q of C, Q over C times what? This is actually the integral of Q over C times A. What's the vector potential? A mu times dx mu. Unsa ning di ba? That is phi dt. Phi dt is just actually what? That's the integral on x0, right? We have a over C here kay phi man to ganiha, right? The potential function. So, it turns out that this is actually correct. And the next thing is that since this is our action, how do we take the... Ganyan, nabantayan ako. Okay, now since this is our action here, we are interested with this part of the action, the electromagnetic part. So how do you calculate the equation of motion? We take the variation, right? So taking the action, let's call this taking of the SEM na lang, no? Delta SEM would be what? Q over C delta of A mu dx mu, right? And this is equal to 0. The variation must be equal to 0. Now, when we apply the variation here, what do we get? QC. This is first, the second, plus second. It acts like a derivative. So, first, the second. So, sa ato pa, this is A mu. Okay? dx mu, right? By the way, we take now the covariant form, ane. Well, we can take the contravariant. Sorry. We might take the contravariant vector na lang. No? Pero sa naman ko tayo summation, good. we are taking the dx mu. So that's why we take the covariant term. Plus what? The variation of this, A mu dx mu, right? Now, the same tricks atong gibuhat last time in actually deriving the, I hope you can still remember. No, murag ang atong lesson convoluted na, no? Actually, it's because there's only one physics. Okay? So, unsay buhaton nato ani? Well, kung ato ni technically ang atong evaluate ang kuan dire ang
Sila ma-address eh.
ha?
Di ba ma-address man sila?
Asang maad? No. This is different actually. That is ano. Okay? Now, in fact, we can actually interchange this too. So, atong buhaton kay, we put D here and X, delta diha, no? The variation. Okay. So, and then let's focus on this part sa. Okay? Okay, what happens if we take D A mu delta X mu? Well, first the second the first, right? This is now D A mu D delta X mu plus partial A mu over partial X nu dx nu delta X mu, right? And so this one is kani siya, right? Sa ato pa, this one is this minus this, right? Diba? So murag libog na sa no kay ang ato ang sa una ordinary karon tensor na atong we're dealing with tensor. Well, that's actually the
Ang galing sir is function niya pa nilang AMU.
ang aim, that's the covariant vector potential, component of the covariant vector potential. Mas libog siya tanawon, right? Isa na sa kapalatandaan that we are actually using really advanced mathematics now. Okay? And so sa ato pa, this whole thing here is this minus that, right?
Yes.
So sa ato pa, this is Q over C. Again, this is the variation of delta S. EM equals kani separate lang na ako, no? Because I will do an integration by parts. So kani D A mu delta X mu, right? Minus what?
A mu
and minus what?
partial A mu over
Kani? Plus lang sa plus kani kay kani og kani, it looks the same. But look at this. Partial A mu can just be taken as delta A mu can just be taken as partial A mu over partial X nu delta X nu. Right? So, sa ato pa, this is that partial A mu over partial X nu. Okay, minus. Okay. Times
hindi na may answer sa control ang partial and makunan siya.
May tabo kay ko, masiro siya. Wait lang, na something wrong diri. Sorry ha.
Minus
wait, dx partial x nu x mu x nu well, we can actually just, the trick here is, okay, anyway, A nu partial dx nu. Okay.
Kaya kung katulad sir, minus.
Ay, okay. Kani siya kay lahi man ni diri, no? Okay. To make things more comfortable, compatible, kay tanaw ni siya, this is delta x mu, delta x nu, right?
Yes sir.
Okay? So, ang atong kuanon dire is, this is, to make the, to make it compatible, ato ni siyang ibali, we have x mu, mu, and this is nu. So, sa ato pa, partial A nu over partial x mu, okay? And this would be what? Dx mu, dx nu, delta x what? Mu. Delta x, yeah, para makombine natin yung dua. Okay. Now, we know that when we integrate this, so say magawas, di ba kane? And this is set to 0, right? Because this is stationary. The integral is actually stationary. Okay, so what we get now is, sa ato pa, this one will vanish. Nakuha? This one will vanish. Why? Because we have, well, we will get now A mu delta x mu evaluated from what? From T1 to T2, but this is 0 at the boundaries, right? That's why this will vanish. So mawala na siya dira. And what is left is kanisya. Na Q over C diha, no? So that would mean that this whole thing here is what?
1.
Well, this plays as a special role such that we can define now a second rank tensor, F mu nu. Okay. F mu, this is F mu nu. Okay, F mu nu to be, okay, we'll just define it in the contra variant. Anyway, we can just raise that index. As of now, we have not defined, anyway, we have not actually have the freedom for A mu here. Wala to siya kuan. But what's A mu is just that's just equal to A mu, A nu, G mu nu, right? That's just A nu. We can go back to A mu by this one, but as this partial A mu over partial x nu minus partial A mu over partial x mu. Or this is actually, in shorthand notation, this is, sorry, murag balik taron lang nato be. I think we can just, this is mu nu, this is mu nu. We can just reverse this one, no? Mu, mu nu. Or this is in notation, this is delta mu A nu minus delta nu A mu. Take with this is what we call the electromagnetic field tensor. Now, in fact, actually, I can just give you directly kaniga. I don't need to go through this to give you this. I can just define this. Right? Pero, nganong ni abota diri nga sa action? Because I'd like to show you that there's a reason for defining a tensor like this. Okay? There's that reason. Sa ato pa, dili ni siya random. Kaya pag ako mag-introduce sa inyo diretso nga, okay, equal na siya sa kani, equal sa ani. Nganong nayana, no? That was actually my question also. The first time I encountered that. The book just defined it diretso. Why? Oh, di ba? Ngano? But in fact, in Griffith's actually nga book, kung siya gibuhat niya, before niya gi-define, he went through the physics first of time dilation, of the Lorentz transformation of the electric and magnetic fields, and you will see a relationship there in such a way that you can deduce this relation there. Nga naa kay makita dito, no? Nga transformation. But I'm doing the opposite. The baliktad nga ano niya. Napay isa. Okay. So we call this the electromagnetic field tensor. So here, the electromagnetic field tensor. So this is defined as F in contravariant form, F mu nu equals partial mu A nu minus partial nu A mu. Okay? Now, of course, you can, this is in contravariant form. You can write this in whatever form that you want. Okay? In fact, you can write this in mixed form. Okay? Or in covariant form, purely covariant form. Okay, you just have to keep track with the, how do you transform this into the covariant? For example, what is F mu nu? By the way, wala ba nang define ba nino? I define first. I will define partial mu as this. Okay, this is a column matrix as this. We'll use the standard Minkowski minus plus plus plus. Last meeting we used this plus minus minus minus, no? I think motong gi-reverse na ako to katuganing negative ganiha. Remember sa katuganing ano ganiha? Tong sa del squared A. Gi-reverse na ako siya akong giano because I want to use the standard nga kadaghanan, di ba sa standard actually. Pero kadaghanan gagamit is minus plus plus plus. Okay? You can use any as long as dapat ang negative if negative ang temporal, then the spatial would be positive. No, if positive ang temporal, then spatial would be negative. Dili pwede nga naay maano dira. Okay. Well, we define this as what? This is 1 over C. Okay, sorry. This is 1 over C partial over partial T del, which is the partial over partial X, partial over partial Y, right? We define this. So sa ato pa, what is now the contravariant version of this? Partial mu would be what? G mu nu partial nu, right? And sa ato pa, by doing this, we now, partial mu would be what? This row matrix or column matrix would be what? G mu nu, what is G mu nu? Minus 1, 1, 1, right? It's just, by the way, we are still in Minkowski space, where G mu nu is equal to what? Negative 1, 0. Now, we will be using this metric now. Negative, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 1. We'll be using that metric now. Okay. And, well, we know the fact that by definition of G, this contravariant metric tensor, di ba? Sa ato pa, this just becomes what? This is minus 1 over C, partial over partial T, del. This is the difference. Now? Okay? Now, you can now calculate the electromagnetic field tensor, the elements of the electromagnetic field tensor. How do we calculate the elements of the electromagnetic field tensor? Well, we use this equation.